Hello everybody and welcome to our webinar today. Today we're going to be talking about distributed denial of service attacks and some things that service providers can do to help both protect yourself but also the internet in general. This is a very important topic because we've seen a lot more of these recently. Before we get started, I wanted to just cover how you can ask questions if you'd like. You'll notice that on the panel, I'm trying to get this to come up, there we go. You notice on the panel that you've got a place to ask questions, and then also, if you don't see that, there's an arrow where you can expand that or then reduce that panel. So ask questions at any time. You don't need to wait until the end. We will answer them at the end, but feel free at any time to type in a question at the end of the webinar. We'll go ahead and cover those. My name is Rick Uzzi. I'm the Vice President of Marketing here at Zecorum. With me is Scott Helms. Scott is Vice President of Technology, and Scott is over all of the folks here, the teams that manage our own internal networks and servers, as well as those that manage networks and servers and CMTS and DSLAMs and whatnot for our service provider customers as well. So Scott, welcome today.
Oh, good afternoon, Rick.
Here's why we're talking about this, Scott. This is really quite startling. Denial of service attacks, distributed denial of service attacks, especially specific kinds, have been really on the increase. And in fact, these numbers here from Prolexic, which is now part of Akamai, shows 371% increase in NTP amplification attacks. You see here average peak bandwidth, 218%, and then 807% increase in the average peak packets per second. So this is really something that has changed just very recently, right?
Correct. We've definitely seen an increase in DDoS attacks, both in terms of who can launch them and who they get launched against, and also how bad they are.
Right. And I'm looking here at the targets, and this is pretty interesting. So, banking, and that's kind of a sleight of hand kind of attack, right?
Correct. You can think of it like the old ideas back when we worried primarily about crime on the street. The idea of a gang that wanted to rob a bank might actually start a fire across town as a way of distracting all the law enforcement groups away from their actual target. It's a good distraction because, generally speaking, the same people who are responsible for protecting their enterprises from DDoS attacks are also the same people who are responsible for responding to compromises and intrusions. Mm-hmm. So if you can tie up those resources, there are fewer eyeballs basically looking at your real attack.
Mm-hmm. A similar analogy, simpler, I guess, would be the pickpocket who bumps into you, right?
Yeah, or if you've ever seen signs when you travel where somebody holds up a sign that says, watch out for pickpockets. Those are actually often people who work with the pickpockets, because most people's natural reaction when you see that sign is to reach for where your wallet is, and so they actually show you where your wallet is.
Thanks for that tip. I didn't know that. Online casinos, gambling, that is what, blackmail?
Yeah, because the casinos typically have to work out of countries that besides the U.S., because we've blocked their payment pathways, a lot of cases they really don't have a lot of recourse legally if someone comes to them and says, hey, if you don't pay us X amount of money, we're going to block all of the traffic that you're depending on to actually make revenue. And one of the other things that's kind of changed is actually who can launch these kinds of attacks. This is really important. It used to be that hackers were technically sophisticated people, and the people who were actually launching the attacks and worms wrote the code themselves. It's not really true anymore. It's actually not very difficult to find online the toolkits that let almost anyone launch these kinds of attacks.
Yeah, I can see why they're so prevalent then. And then we've got security firms, spam kinds of things. To explain that.
Yeah, so a lot of times those are what I call advocate attacks. Basically, people that are attacking organizations that oppose something that they're doing. So we saw the Spam House attack was a good example of this, but also security firms like antivirus companies. If you think about one of the common tactics for hackers to try and get money is to use an attack called ransomware. And this is basically the idea that you can infect a PC with some typical kind of annoying virus, pop-ups, whatever, but you also send to that same PC an advertisement that says, I can fix this problem for you. And of course, real antivirus companies can identify this stuff and remove it. But one of the things that a ransomware company or organizations will do is they'll actually attack Norton and Symantec and the other AV companies at the same time as they launch a wave of ransomware to slow down the ability for the legit AV providers to remove this kind of stuff.
Right. Okay. So here's, I guess this is really what it comes down to, is that we're not doing source verification. So there's an analogy here of just postal mail, right?
Yeah, so I mean, if you think about our normal mail system, we may not send as many letters as we used to, but it's really the same idea. There's nothing that prevents me from taking an envelope and putting any sender address I want to on it and putting it in my mailbox. And you know, you used to see these kinds of jokes and pranks where someone would sign somebody up for catalogs and those kinds of things. Again, because there's no verification that you sent in the postcard that said you wanted a specific catalog. And this is really the same problem that we have with this specific kind of attack on the internet.
Yeah, kind of like when you take one junk mail mailer's mail and put it in the envelope,
right,
return envelope of another guy. So.
Yeah, exactly.
Right. Okay. So talk a little bit about the protocols here. Now, TCP is something that a lot of people have heard about, but talk about UDP because they may not be as familiar with that.
Okay. So UDP and TCP are both what we'll call layer 4 protocols, and that's a layer in the OSI model. And I promise I won't get any deeper than that. But basically, this is the protocol layer just above IP. And these are transport layer protocols that are how we communicate across the internet once we start getting to the port layer. And we see different kinds of applications choose to use either TCP or UDP for different reasons. And they were developed to do different things. So TCP is the more, I guess, commonly known one. And a lot of protocols like web browsing and email, FTP, a lot of the things that we're used to doing run across TCP. And with a TCP connection, you have just that. You have a socket connection between the source and the destination. And so it's very difficult, really it's impossible to spoof a TCP connection. UDP, on the other hand, which is used for things like, in this case, you've got a SIP phone up there and video streaming, those are often used for very lightweight protocols, things that need to be fast, and we don't need that kind of guaranteed socket connection that we use in TCP protocols. So that's kind of the underlying difference. In TCP, you have that nailed-up connection, almost like a circuit, whereas with UDP, it is a series of envelopes.
Got it. Now, we talked a little bit about NTP earlier, just some of those stats here. So these are really, this is what's being attacked now, is that right? Because these are UDP kinds of things?
Yeah, these are DNS and NTP. DNS stands for Domain Name System, and NTP stands for Network Time Protocol. These are both very common UDP-based protocols that we use on the internet. They're also glue protocols, right? So these are things that customers may not be aware of, but we as service providers know and use, and customers use without really being aware of it. DNS, of course, is what we use to translate names like CNN.com or Zquorum.com into an IP address that we can actually send packets across the internet to. NTP is what we use very commonly on our Windows and Macintosh PCs to be able to actually synchronize and get correct time. And there are a lot of public NTP servers out there. These are certainly not the only UDP-based protocols. These are just the common DDoS attack vectors right now. There are others out there that could be vulnerable, but these are, like I said, very commonly deployed and easy to manipulate.
Okay, so let's we're not talking about spam today. We're not here to talk about spam, but let's talk about the kind of the parallel that we had 10 years ago with spam and people who had certain kinds of servers, or let's say service providers, or even companies not doing what they should.
Correct. I mean, we used to have the problem of open relays, and people would spam through a service provider or an enterprise network. It still happens every once in a while today, but it's really the same kind of issue where we want to be good actors on the internet. We want to try and prevent these kinds of attacks, even if they don't directly affect us, or even if we're not the target of the attack. And so it's very similar in that regard, where we want to secure our networks so that our customers don't become infected and become part of a problem.
Right. So let's go ahead and kind of diagram this out on how this all works. So if we've got the internet out here, and then let's say we've got a cable company and their infrastructure, their gateway router, their CMTS, one of many subscribers
Sure.
out there. And then also connected out on the internet, totally unrelated network, we've got a DNS server, let's say, and then playing our victim right here. We've got our victim, and we can go ahead and just to identify them, we're going to put IP addresses up there that indicate that they're on totally different networks. So this being the case, explain I guess there's the source and the destination on these packets, right?
Right. So in a normal situation, let's say the subscriber is going to try and pull up a website. Part of that normal kind of process is this computer is going to send a request to the DNS server, and he's basically going to send it from his IP address as being the source, and then of course it's going to go to the DNS server. And because DNS is a UDP-based protocol, that's what actually determines where the DNS server will send the responses to. So this is a normal scenario. The IP address and the source is coming from the subscriber's PC, and we're going to the name server.
Got it. All right, so let's look at a situation where there's some spoofing going on here.
Right. So in this situation, we've got our zombie over there on the right side, and so this is an infected PC, and what we can see is that what the zombie has done is, instead of putting its source address, its own source IP address, into the packets that it's sending to the DNS server, it's actually putting in the victim's IP address, and this is kind of the essence of the attack. Now, one thing I didn't talk about is that the other reason why DNS and NTP get targeted a lot is because they're also subject to something called amplification. So this one zombie can send out a really small packet and get back in response a very large series of packets. Something like 20 times the size is really easy to do with DNS.
And when you say back in response, really you're saying it goes to the victim.
Yeah, it's going to go to whatever the source is, right?
Yeah.
So in this case, instead of coming back to me, it's going to go to this victim out here. And like I said, I may only have sent a few hundred bytes to the DNS server, but the DNS server may send out something like an entire K or a few Ks worth of data. And when you magnify that by thousands or even hundreds of zombies across lots of different DNS servers that zombie can talk to, that's where you get that really big wave of data to the victim.
And what's an example of that? DNS, is that like a zone file, or what kinds of things are you doing?
So DNS is normally what we use for trying to turn an IP address, a name into an IP address. We also do the reverse. We turn IPs into names in the reverse record. We can get MX records, which tells it where the mail for a domain goes. And then there are longer records, like the start of authority records. Zone transfers used to actually be a target. Very few DNS servers actually allow zone transfers anymore. That would be even bigger.
Right.
But the start of authority records can be quite large, and some of your authoritative name servers, if you're running an authoritative name server, have lots of information that can be queried quite small from a quite small request.
Okay. So basically, what we have is this person's lying here,
right?
As they say, this person, the zombie or infected machine, has got code on it that's doing this and lying about the source. So let's talk about BCP38, which is, sounds kind of scary, but really it's just an RFC, right? And it's for no spoofing.
Yeah, and it's been around for a long time. It's an idea that the equipment manufacturers have known about and implemented quite a number of years ago. And yeah, that's really all it is. It's just the idea that the network infrastructure knows, just by its nature, where it lives in the network. Your CMTS and your routers know what should be coming from your customers in terms of what IP routes, and what should be the outside of your customers. And so BCP38 is just a way of doing that kind of filtering automatically.
So if we look back at our last picture here, BCP38 is, as you say, it's some kind of a filter that checks when this packet comes in. Is that right?
Yeah, absolutely. I mean, what happens is when that packet goes out, the CMTS is going to make a determination of whether or not that source address is actually inside the interface that it received that on. And since it's not, it's going to throw it away.
Got it. Okay. So it basically checks it and then tosses it.
Exactly.
So a lot of what we talked about is really, from the cable provider's perspective, is how they can help prevent their customers from participating in an attack like this, right? So most of the, I guess, the impact on that, or they're maybe, let's say, implementing BCP38 is going to be to help protect the internet at large. I guess, is there some benefit for them as well from the standpoint of traffic? And
yeah, absolutely. I mean, if you have a lot of customers who get compromised in this way, if you're doing BCP38, then basically those packets never transact your network. They never leave your CMTS or never cross your router, and that saves you a tremendous amount of capacity on the WAN side. You can quite literally starve yourself out by having subscribers take part in an attack, either on your WAN connectivity or on your DNS server, which will also cause your subscribers to see the internet is quote-unquote not working.
Right. But as we have here, the golden rule, if everybody were to implement this, you want to be treated obviously the same way. So if everybody implements this would be much less of a problem.
Yeah, we would eliminate about 70% of the DDoS attacks on the internet today. Now,
there's that other golden rule. So what should providers who want to maybe look at implementing this, are there some things they need to keep in mind where this could maybe have a negative impact?
So the biggest thing I would say is make sure that you talk to your equipment manufacturer first. Make sure that you're running a version of firmware that supports BCP38. And the different manufacturers have different ways of turning it on. Juniper, Cisco, Aris, they all have their configuration. So just check with your equipment manufacturer. Make sure that the code version you're running on has a good implementation. Some of the, like I said, BCP38's been around for a long time and it's been implemented for a long time, but some of the early code versions didn't work as well as you would like. If you can, it's always better to test before you deploy live on your network. But at bare minimum, open up a ticket with Cisco or whoever and make sure you're running a version of firmware that is going to be happy with BCP38. It is also possible, it's very unlikely, but it's possible that you'll run into a customer who is trying to do something legitimate with a quote-unquote spoofed IP address. There are a really small number of cases where that actually isn't a misconfiguration. And it's a little more complicated if you're multi-homed. There is another protocol called BCP84 that covers how to deal with multi-router, multi-homed backbone connections.
Now you mentioned routers, but is it done on the router, on the CMTS? What's the best place to do it?
So the best place to do it is as close to your subscribers as possible. So if your CMTS supports it well, do it on the CMTS. If not, then certainly it's a good idea to do it on your router rather than not doing it. But the closer to your subscribers, the less complexity you have. And frankly, the smaller amount of work the networking equipment has to do. Because if you think about it, if you have 3 CMTSs and instead of running BCP38 on your CMTSs, you push all of that up to the router, well, your router has 3 times the number of networks it has to think about as compared to each CMTS. So it's better to run it closer to the edge.
That makes sense. So BCP38, let's just give a little bit of information about that. People can go out and do a little more research on that. But there is a website called bcp38.info that people can go to where they can get information. And we've got up here just a couple of, what are these, kind of example configurations?
Yeah, just some config snippets and some information on Cisco. Cisco calls their implementation unicast reverse path filtering, or URPF. And Arrow's just provided us basically a configuration snippet for the C4.
Got it. Okay. And the other day we were talking about do you do this or not? Mm-hmm. And I guess one reason maybe that some providers haven't implemented this is probably just not being educated on it, and it hasn't been a huge problem as far as these types of attacks maybe since recently. Is that right?
I think that's the main thing. I think it's the main. Then this goes back to again the spam analogy. You don't really fix things you don't have a problem with,
right.
and it wasn't a big issue until the last couple of years. Mm-hmm. So I think the main reason people haven't turned it on is just because they haven't known about it, because they haven't needed to know about it.
Yeah, and actually I was talking to Paul Ferguson, who's one of the guys who wrote the RFC, the BCP38 RFC. And he said it's really security 101, but he said what happens is that, in fact, I love this phrase that he uses, is dog see squirrel, because it's just like you're reacting to the latest thing. You're distracted by the latest threat, the latest zero-day threat like Heartbleed or something like that, and that's what you're focusing all your resources on. But he said this is really security 101, right?
Yeah, absolutely. I mean, there's a few things that a service provider really should do. And IP source filtering is really one of those foundational pieces, because not only does it prevent this kind of specific, NTP, DNS attack, it'll prevent any kind of spoofing attack. Mm-hmm. And frankly, I would tie it with, if your CMTS supports it, DHCP source verification as well. And that really helps tighten down what can and can't go through your network. A couple other things, and definitely service providers should be aware of these as well. Make sure your DNS servers aren't open to the public, right? You really only want to have your customers accessing your name servers, because even if you do all of the right things and make sure that your customers are behaving well, if your name servers are open to the internet, other PCs out in the world can use your DNS server as part of a reflection attack. Same thing for an NTP attack. Mm-hmm. So we really want to make sure that we're keeping all of those foundational services as secure as possible and restricted only to our end users.
Which brings up a question. So the DNS server is being open, but there are, I guess, when people are using these types of tactics, there are DNS servers that are open out there that are meant to be open, right?
Yeah, absolutely. I mean, if you think about, Google runs public DNS servers. OpenDNS runs public DNS servers. Several other organizations do, and a lot of people have name servers that may not be publicly accessible, but may be accessible to hundreds of thousands, if not millions of people. Mm-hmm. Because most of the backbone providers that we as ISPs connect to, they also provide DNS service. Mm-hmm. We may not know about it, but our IP addresses, because AT&T or Sprint or whoever allows us to route through them, are allowed to reach those name servers. And unfortunately, the people who commit these kinds of attacks have taken it upon themselves to really find all of those name servers. So even if we don't use them, we don't know they're out there. They're there, mm-hmm. and the attackers know they're there.
Right. Okay. Well, great. Okay, we'll take some questions, but before we take questions, I'm going to do a little commercial here, because this is some exciting news that's taking place just today, and it's specifically relevant to NCTC member companies. We've got our new product, RF Inspector, out as of today, and the nice thing about NCTC members is there's a server-side component to this, but that's free for NCTC members. So tell us a little bit about this, Scott. So this is a app that right now is available on Android tablets for $9.95 per year, and in a sense, it basically can take the place of a meter, right?
That's correct. So RF Inspector leverages the ability in the new generation of cable system on a chip, and we're beginning to see modems that have both the hardware and the firmware out there deployed in the world. And what it lets us do is actually see the entire downstream spectrum So not just the channels that the cable modem itself is tuned to and using, but all of your analog digital TV, everything in the downstream, all the way up to a gigahertz, is viewable. And what's really nice about this is not only is it do we get away from a physical meter and some of the expense and the challenges there, but we don't have to drive to wherever it is we want to take a spectrum sample. We can get an idea of what the spectrum looks like from anywhere we're at, as long as we have internet connections.
Mm-hmm. Great. And as I say, so there's two pieces to this. So they can go to the Android store. You can just search on Zcorum and you'll see RF Inspector up there. Download the app. It's actually a free download on the app. And then in the app you purchase a subscription for $9.95 per year. But before they do that, they have to, before they can purchase a subscription, they have to have actually the server software installed.
Yeah, we did that to make sure people didn't download and buy it without, and then find out that they couldn't actually get the server up and going. So
Right.
you get the server up and going, and then you can buy the subscription.
All right, so we've got on the screen there some information about where you find that. Just go to nctconline.org, click Vendor Resources, select Zcorum, and then you'll see RF Inspector and specifically a place where you can download that software. So let's take a quick look at some questions here. As far as impact, Scott, what should we expect the impact to be for subscribers if we turn on BCP38?
So if everything's working, there should be zero impact. This doesn't change the behavior of normal packets. And if you do have a customer, and this actually can happen if a customer has a laptop that they bring back and forth from work, and they maybe have a static IP address or an IP address from the office network, and then they also get an IP address when they come home, their laptop may not be sure which one to use at a given point, or it may actually source from one of the office IP addresses improperly, and they'll get flagged. But that's a very rare circumstance, and it won't work anyway. So even if it was going out before, they were seeing an error before you turned on BCP38.
Right, and it's really, there's really very little chance that there'll be any impact. Like you said, if they check with their equipment manufacturer, you might have that odd situation. Right.
Yeah, that's really the only scenario that we really see much of a negative impact is if they're running an older version of firmware, and there were some bugs in some of the first versions of BCP38.
Mm-hmm. Let's see. What are some of the legit ways that people spoof IP addresses? So I guess that's the
exception. So really the only time that you see a legit circumstance is you'll sometimes see people who are using business services over DOCSIS, and they're trying to connect offices across a cable plant, and you can actually do this quite well. But if the configuration is not quite right, you'll actually see leakage of IP addresses, and it's more of a mistake than a legit use, if that makes sense. So it's really less about a legit, more of an inadvertent.
It's one of those things that people do because it happens to work at the time.
Correct. Yeah, it works, and so they assume that it's okay.
Yeah.
And it's really kind of halfway working, and it's only working because business service over DOCSIS configuration is leaky, basically.
Mm-hmm. Should we consider RPF in loose mode versus strict mode when implementing BCP38? That's from Jamie.
That's an excellent question. Okay, so this is a Cisco specific question, and really what Jamie's talking about is there are two ways to look at implementing BCP38 RPF in a Cisco framework. So the problem is loose is too permissive, and to my mind it really doesn't do much, because it doesn't really prevent spoofing in all cases. So to really secure your network, if you want, you can turn on loose and then just pay attention to your logging, and then go back and turn on strict. But unless you have a really complicated scenario in terms of I may have, a network of 30 or 40 CMTSs and multiple locations and head ends, and I'm bringing all of that back to a single router, and I'm running my BCP38 checks at that single router, in this case RPF. That's the only scenario I would really consider doing loose in production. And again, this is really what you want to do. One of the reasons why you really want to focus on pushing your verification as close to your customers as you can, because that simplifies those checks.
All right, so Rusty's asking, what is the current version of BCP38? Is there a version?
No, there's not really a version. The only version thing that you really need to be concerned about is making sure that your firmware version is up to date and supports BCP38. BCP38 is actually RFC 2827, I want to say, and so it has a description of a way of doing filtering. Hasn't changed since it was published. Just the implementations on the different networking equipment have changed.
Okay, I think we answered this, but we'll cover it again. Is it recommended to do source verification at the CMTS or the gateway?
If your CMTS does it, I would definitely do it there. The only other thing that I would consider is what is your load on your CMTS? Because there is some additional load. It's not huge, but it is a percentage point or two on CPU. I would look at that as part of, if you have a really heavily loaded CMTS, maybe you've got a 10K with 8 or 10,000 modems on it and still running PRE2s, you're probably pushing the most of what the CMTS can do already. So in that case, you don't want to add that one needle that may be the thing that the straw that broke the camel's back. Right. That's really the only case I would think about doing it on the gateway.
Okay, and could BCP38, this is from Robert, have any impact on VoIP at all?
That's actually a really good question, because VoIP is most often, a UDP protocol too. But BCP38 really doesn't even work at layer 4. It really works at layer 3, so it's only doing IP verification. It doesn't look at VoIP traffic any differently than any other traffic. So the only thing I would say in terms of implementation, when you're doing your implementation, or even better when you're doing your testing, you can turn on BCP38 on a per interface basis. You can actually turn it on one of your upstreams, upstream that you have as a test port in the head end. Test all of your networks that you have on the bundle group on the CMTS, and make sure that all of the IP networks can route, and try putting in an IP address that shouldn't route to make sure that it doesn't work, right, when it shouldn't. As long as all of your IP blocks route correctly, including any that you assign to your EMTAs, you should not have any impact on voice.
Okay. And I think that may be the last question. I'll ask one, though, just in case we get anything to come in here in the last minute. Are embedded routers and CPE gear going to be implementing this?
Yeah, so this is actually one of the good pieces of news. As we move, especially into an IPv6 world, we'll start moving away from commonly doing NAT. Today, if we have an embedded router or somebody has bought a gateway on their own at home, it's almost invariable that that device is doing NAT. So in that case, the PC itself can't spoof very well because something else is rewriting all of the sources already. So from that standpoint, that's not really a problem. But as we move to IPv6, that NAT layer goes away. And so now suddenly you have publicly routable IP addresses behind these embedded routers. And the good news is that Cable Labs made part of the eRouter standard to do BCP38. Mm-hmm. And a lot of the manufacturers of routers that get sold to customers directly are also implementing it.
Okay, well, great. So hopefully at some point in the future, everybody will be doing this, and it won't be something we'll have to worry about so
Correct.
much. All right, well, great. All right, well, thank you so much, everybody, for attending today. We have a recording of this webinar that we'll be putting up on our website, and maybe I think we'll possibly even email it to folks that have registered for the webinar. So we do appreciate your time today. Thank you so much. Again, check out RF Inspector. You see our contact information up there on the screen as well if you wanted to reach out to us. And Scott, I really appreciate your time today. Thanks. It was very informative.
Thanks, Rick.
Thank you.